गुड मॉर्निंग बच्चों, आज हम जीरो ऑर्डर रिएक्शंस डिस्कस करेंगे। सपोज हमें एक रिएक्शन दी हुई है, रिएक्टेंट ए गिव्स प्रोडक्ट बी एंड इट इज ए जीरो ऑर्डर रिएक्शन। तो हम इसका जो रेट है दैट वी कैन राइट एज माइनस डी ऑफ ए अपॉन डी टी इज इक्वल टू के, that is rate constant into concentration of A to the power 0, and we can, because this is a zero order reaction, so we can write this as minus dA upon dt is equal to K. So this is the differential equation which represents zero order reaction. अभी हम इसको इंटीग्रेट करेंगे from time t equal to 0 when concentration of A was A naught to time t when concentration is A. So let us integrate this equation from A naught to A minus dA will be equal to K dt from 0 to t, because concentration at time t equal to 0 is A naught and at any time 2 it is A. So this will become A naught minus A is equal to KT, and it can be rearranged to write as A equal to A naught minus AT, and this is the integrated rate law for zero order reaction. Okay, so we will use this equation for our subsequent analysis, and here I will write this equation as A, that is concentration of A at any time t is equal to concentration of A at time t equal to 0 minus KT. Okay, so this is the इंटीग्रेटेड रेट लॉ फॉर जीरो ऑर्डर रिएक्शन। अभी हमें मान लीजिए इसकी हाफ लाइफ निकालनी है। सो हाफ लाइफ क्या होती है? व्हेन रिमेनिंग कंसंट्रेशन विल बिकम इक्वल टू इनिशियल कंसंट्रेशन बाय 2, एट दैट टाइम दिस इज कॉल्ड हाफ लाइफ। सो लेट अस पुट ए नॉट बाय 2 इंस्टेड ऑफ ए will become equal to A naught minus K into time t is t half. Okay, so this will give us KT half is equal to A naught by 2, or we can write T half is equal to A naught by 2K. So this is the half life of zero order reaction. So we can say that half life of zero order reaction is directly proportional to initial concentration of A. Half life is directly proportional to initial concentration of A. Okay. When we will discuss the first order reaction, we will find that half life of first order reaction is independent of initial concentration. Okay. Now let us find T lifetime. What is T lifetime? What is lifetime? That is when this reaction is 100% complete. That means when remaining concentration of A will be 0, then T is known as T lifetime. So let us write the same equation, that is A equal to A naught minus KT. This is our integrated rate law. Now I will put concentration of A as 0 equal to A naught minus K into T lifetime. So T lifetime for zero order reaction will be equal to A naught by K. This we have found earlier that T half life was A naught divided by 2K. So we can say that T lifetime is nothing but 2 into T half. Okay, that means the time required for 100% completion of zero order reaction is double the half-life. Okay, now if we plot this in a graph, then we will find this. Suppose concentration of A versus time, if I plot, then this will be a straight line, because the equation is A equal to A naught minus KT. It is like y equal to mx plus c, where slope m is minus k and y-intercept is A naught. So we can say that this is A naught and this is the equation. This line, this straight line represents the integrated rate law for zero order reaction, and suppose this angle is theta, then this is the slope tan theta, so this will be tan 180 degree minus theta, that will be the slope of this line with x-axis, and the slope will be equal to minus k. So if the slope is this angle theta is given to us, we can find the value of rate constant. Suppose the theta is 45 degree, then what will be tan theta? That is tan of 180 degree minus 45 degree, that will be minus 1. So slope is minus k, so I can write minus k equal to minus 1, so k is 1. So its rate constant is 1. Okay, so this equation represents the, this line represents the, this zero order reaction, how the concentration of reactant is changing with time, starting from initial concentration, that is A naught. Okay, and I can also show the when the concentration of A is 0, okay, then what is the time? That is A naught by K, we have found out. So this intercept on x-axis is A naught by K. When the concentration of A is 0, the time is A naught by K. Okay, so now we take some questions based on this reaction. Before that, I will draw the graphs, the 4 graphs that are known for this. That is, one is the rate of zero order reaction, rate of reaction versus time. It will be straight line because rate was equal to K. It is independent of time. Similarly, if I write rate versus concentration of reactants, that is A, then this will also be like this, because rate doesn't depend on concentration of A. Okay, if I draw this say your concentration of A, that is with time, that we had just now drawn, it was varying like this with slope equal to minus k, and this intercept was A naught. Okay, and this was A naught by K, that is the lifetime of the reaction when concentration becomes 0. Okay, and suppose one more graph, that is, if I want to draw the graph of concentration of product versus time t. Okay, because as the A concentration is reducing, the concentration of B is getting increased, because our reaction was A gives B, and because concentration of A is given by A naught minus KT, by this we can see that at any time t, what will be the concentration of B? That will be KT, because number of moles of A reduced in time t is KT, and same will be the number of moles of B produced. So concentration of B at any time t is Kt. So the graph for concentration of B versus time will be a straight line with slope of K. Okay, so this is the another graph. With this, our theoretical analysis of zero order reaction is complete. Now we take some questions. Suppose a question is given to you that a reaction takes 20 minutes for 40% completion and 40 minutes for 80% completion. Find its order of reaction and rate constant. Okay, so we have to find the order of reaction and rate constant. So how we will do? Just by observation we can see that this is a zero order reaction because it takes 20 minutes in 40% completion and double the time, that is 40 minutes for 80% completion. Means it is a unitary method, and zero order reactions concentration behaves by unitary method we can calculate. Okay, because we had seen that its half life was A0 by 2K and its lifetime was A0 by K. Suppose I start with A0 concentration, then I know that at T equal to T half, the concentration of A was A0 by 2K, and at T equal to lifetime, the concentration was 0. Okay, so we can say that, and lifetime was nothing but A0 by K. So this is the, at T equal to A0 by 2K, the concentration is 50%, and another A0 by 2K. So this time is A0 by 2K up to half life, and this another A0 by 2K. So total becomes A0 by K. Okay, so we can say that इसकी जो कंसंट्रेशन है वो A0 by 2K टाइम में 50% हो जाती है और अनदर A0 by 2K टाइम में 0 हो जाती है. ओके, तो ये हम यूनिटरी मेथड इसमें डायरेक्ट लगा सकते हैं. ओके, दैट मीन्स वी कैन से दैट दिस इज ए जीरो ऑर्डर रिएक्शन just by observation, because it for 40% completion it takes 20 minutes and for 80% completion it takes 40 minutes. That means in each 20 minutes it is completing 40%. So it is a zero order reaction. Okay, now how to find the rate constant? So we will just write the rate equation. A equal to A0 minus KT. So let us write for 40% completion. 40% completion means remaining concentration will be 60%. Suppose हम 100 से चालू करते हैं. Let A0 is equal to 100 moles per liter. Then what will be A? A will be 60 because 40% completion means remaining concentration is 60 equal to 100 minus K into time is 20 minutes. Okay, so we can find the value of K. 20K is equal to 100 minus 60, that is 40. So K is equal to 2. Okay, so that is how we have found out the value of K. अब हम अगर सेकंड वाला भी लगा देते हैं. Let us see by second data what is the value of K. So second में 80% completion means remaining concentration will be 20. Initial was 100 minus KT. Okay, and time T is 40 minutes in this case. So again we will find that 40k is equal to 80, that means k equal to 2. So by both these data we have found the value of k and it is found to be same, which confirms that this is a zero order reaction and its rate constant is 2. So that is how we can find out by applying the unitary method, which can be easily applied for zero order reaction. Suppose आपको एक क्वेश्चन दिया है कि a reaction, zero order reaction, it is given that a zero order reaction takes say 40 minutes for 10% completion. Okay. Find time required for say 33% completion. So how we will do? We can do by unitary method. Just we told that for zero order reaction we can apply the unitary method. So for 10% completion it takes 40 minutes. For 1% it will take 40 divided by 10, and for 33% it will take 40 divided by 10 into 33. So it will be 132 minutes. So that is how you can find out. And just you can see for 10% 20 minutes. So for 20% 80 minutes. For 30% it will be 120 minutes, and for 33% it will be 132 minutes. So by unitary method you can just apply and find out the time required for any percentage of completion. Okay, I think we have completed this zero order reaction in all respects. With this I wind up this session and wish you all the best. Thank you.